I'm going to go ahead and get started. Welcome, my name is John Lambert. I'm a security group manager at Microsoft. Today I'm going to talk about the security engineering behind Windows Vista and how it'll be different from every other Windows release, primarily through the integration of the security development lifecycle into the engineering process into Vista. We've worked with the security research community a great deal over the last few years and learned a lot, and this presentation is going to reflect all of the lessons that we've learned in engaging with this community. Part of what we wanted to do today was to give back to the community, share our process, tell you what we're doing, gather your feedback, tell you what we're doing in terms of the heap and other technologies like that. I hope what you'll see, what you'll think by the end of this presentation is that you'll hear that we've listened and that we've tried to take the best of what we heard and apply it to Vista. I joined Microsoft about 6 years ago. I've been fortunate enough to have what I call a front row seat at security at Microsoft for those 6 years. I was there to see the company deal with the challenges of Code Red, NIMDA, Slammer, Sasser, et cetera. But I've also seen the company respond in terms of the efforts behind the Windows stand down or the Windows security push, things like Windows XPSP2 and Windows Server 2003. Finally, the formulation of the security development lifecycle in SDL and its adoption across Microsoft. I happened to be at the meeting where we asked Bill to write what became the Trustworthy Computing Memo. It was not the day that security dawned at Microsoft, but it was really us going to Bill and saying, Bill, we need to do something about this across the board at Microsoft. We need to focus and it needs to start from the top down. I run a team inside the Secure Windows Initiative at Microsoft dedicated to helping product teams improve their products. What you'll hear in this deck today is about how we're doing and taking security engineering and how we've implemented that in Windows Vista. You'll hear about the overall security strategy and the game plan behind what we did. We'll do some deep dives onto the major security initiatives in Windows Vista. You'll hear about the unprecedented level of scrutiny that Vista has gotten by members of the security research community and some of the results from there and the things that we've learned. I'm here to take any engineering-focused feedback that you have and take it back to the product team. Just to set your expectation, this is not a presentation about security features, so I will not be talking about BitLocker or public key infrastructure or Kerberos or any of those things. This is really about the engineering process that's behind all the different features in Windows Vista. So let me start off by setting a little context. So the Security Development Lifecycle, or SDL, is how it takes all the lessons that we've learned and really integrates security through the engineering process from beginning and to end. And SDL is something that we do on all major Microsoft products, and this presentation really focuses on how we implemented SDL for Vista. We learned things during the Windows security stand down, like, for example, doing threat modeling after the code has already been written is not the greatest time to do threat modeling. And so we've taken things and integrated them at the appropriate time in the life cycle. So it starts off with security training and education. Then it moves on to security planning, threat models at design time, taking advantage of compiler hardening and code scanning tools at implementation, security testing, et cetera. So the overall game plan behind Windows Vista, we really had a really special opportunity in Vista, which is we had a chance to take all the different lessons that we've learned from security releases at Microsoft before and apply it for the first time to an end-to-end operating system release, a major operating system release. And so we could really go and retool the entire process to take advantage of all these things. One thing we did is we went and looked at all the MSRC bulletins that we had shipped, and we wanted to understand this is an interesting set of defects in the sense that these are all security bugs that somehow had gotten past our engineering process. We didn't catch it in design, we didn't catch it at implementation or testing, and so these bugs were a very interesting set to study for that reason. Went back and tried to understand how can we catch this bug in design more upstream in the process, and what tools do we need to go right so that we can catch these tools? And we took that set and actually took that feedback and changed the engineering process in Vista to apply those things. And clearly, just looking backwards is not enough. The attacks will always get better. So we also look forward at what we thought were emerging areas of threats and what we thought would be the types of attacks people would do against the new features in Vista and try to make sure we were solid against those things. So the overall security approach, the way I like to think about it is really 4 major tactics. The first is really to go take this concept of least privilege and go apply it consistently throughout the architecture of Windows. And so Vista has probably the biggest reduction in privilege level of any Windows release ever. And we've taken this concept of least privilege and applied it to applications, things like the browser, and also services. And I'll spend a little bit of time talking about that. If you work on something like Windows, the name of the game is how do you scale. The Windows code base is very large, and you need to be able to go and really scale to get any kind of consistency of result across the entire code base. And so we took techniques that we could automate, and we tried to understand all the different things that we could automate, and put a tool behind them, and then wire that tool into the process. And so we can go get consistency throughout code base. So some of these things are taking our source code scanning tools, prefix and prefast, and tuning them to find buffer overruns and other security defects. These are things like taking file parsers or RPC interfaces that are commonly targeted and doing fuzzy testing across those, doing things like identifying a set of APIs that lead to unsafe coding practices, the stir copies, the stir cats, etc., and just banning those throughout the code base. And so these are things that we could just simply automate, build a tool and wire it into the process and automate. The next part was really taking security experts and going back and having them sit with a product team and put on their adversarial mindset and think about all the different types of attacks that the component team themselves might not have thought about. And this involved attack surface reviews, threat modeling reviews, really digging into the design, and also, where necessary, going and doing penetration testing. And the last part of the strategy was defense in depth. We know there will be bugs, despite our best efforts, that will get through the process. But what we want to do to as much as our degree possible is to minimize the abilities for those bugs to be an exploitable condition. And so we've done a number of improvements in terms of the stack, the heap, and other areas so that even if a bug does get through our process, we really minimize the ability to get reliable exploitation of those defects. So this is kind of the overall game plan and basically the formula for the rest of the presentation. One way to describe the changes that we've made in Vista is really to compare it with the XP development process. And the way that you could characterize the XP development process is, it was by and large, security was the responsibility of the individual developer, and that certainly hasn't changed, but it really kind of stopped there in terms of they went to training, they developed threat models, they did component level testing and reviews. When they checked it into the main source tree of Windows, they had buddy code reviews, and then it's pretty much in the product at that point. There were some things that were done across the entire code base. If any bug was tagged as a security bug, there was a person whose entire job responsibility it was to make sure that those bugs did not get accidentally punted or resolved as won't fix or things like that. We also did have certain tools that we would run across the code base just as a whole. So this is Windows XP. Windows Vista, one of the first changes that we made was we tried to understand how can we prevent defects from getting into the code base in the first place. And so we instituted this concept called quality gates. And quality gates were about, if there's a way to technically check the code for some kind of issue or defect or vulnerability, to go wire that check into the check-in process so that, you know, Windows has quite a large set of developers that work on it. And so it's not like there's one source branch and everybody checks directly into that. They check into their upstream branch, which goes downstream, and finally you're into WinMain, which is the main source tree for Windows. And so we can put these quality gates at various levels up, and so the code, all the defects that they can screen for, just never make it into the product. And so some examples of things that we automate through that are things like getting rid of banned APIs. So there's about 120 functions that we've said, you know what, our root cause analysis has showed us these commonly lead to security defects. About 10% of bulletins could have been prevented if we got rid of usages of these banned APIs. So we said, new code in the product, we'll not use these APIs, period. And we put a technical check into the product. And so all new code that comes into Vista does not make use of these APIs. Additionally, we could have certain code scanning tools like prefast go and look for certain types of security defects upstream. And those set of bugs, they just never made it into the product because they were fixed before the code really ever made it in. Next, we augmented what we did across the board for all the code. So yes, teams had to do threat models, but in Vista, we actually had a set of security experts go and check the threat models. And if we saw threat models that needed more help, or they needed to really go think about, no, it's not okay to mitigate that threat in documentation, we really got to go do a mitigation in code for that. That was the type of back and forth that the security experts would join with the product teams and review their threat models. And if they weren't up to snuff, we would actually go help the team get them up to snuff. I mentioned things like getting rid of these unsafe APIs. That's a great thing to do for new code that's inbound, but frankly, there's a lot of old code in the product that makes use of these unsafe programming practices. And so we wanted the entire code base to be clean by the time we shipped. So we went and got rid of 250,000 different instances of stir cat, stir copy, all those 120 different functions across the code base. This was seriously just a massive cleanup effort, month to month to month, just slowly whacking away at this stuff. And the net is, new code, old code will be cleaned by the time we ship on this stuff. We also went and annotated a lot of different APIs with SAL, and I'll walk through SAL in the next few slides so you can get a sense of what it's about. But it really helps make the tools a lot more intelligent when you can add more annotations to the code base to make the tools that much smarter. As we know, things like in cryptography, attacks increase, and methods that seemed to be secure a few years ago now look weaker and weaker and weaker. And so we did a scan for all the crypto usages across the code base. If we found somebody that had re-implemented some other version of crypto, we went and made them use the official libraries. We went and understood for every version of crypto, is it being used for some security reason? Is there actually a security effect by using this crypto? And if it was a weak version of crypto, then we made them migrate to the new secure versions. The only cases where that wasn't the case was for interop with existing standards, where the standards basically said you need to use MD4, you need to use MD5 or whatnot. We also did a major effort to harden our services, and I have a deep dive on that, and I'll wait to talk about that. Windows includes code from third parties, drivers being an easy example of that. Clearly, it's not just enough to secure the code that we write. We want to secure all the stuff that ships on the DVD now that Vista is. And so we had a process for going and understanding what was the attack surface and what was the security put into these third-party components and make sure it was really up to stuff with our standards. We also improved the mitigations across the board. These were things like the compiler innovations in terms of stack protection, changes to the heap, and making sure that that was being adopted across the board. And we also did privacy reviews. So that was across all the code. We also took a look at a slice of the product that was basically on the attack surface. So this is stuff that runs with high privilege, that listens to the network, that's been a common source of MSRC bulletins in the past. And for that, we dug in deeper. So we went and took security experts and had them go look at the design and the attack surface. We had them go look at the threat models in depth. And where we saw areas that seemed weak or seemed complicated or made some very strong security guarantee or was really a linchpin of security, we had implementation review by penetration testers. If we found issues in any of these processes, we would drive security pushes in some cases, because as we know, penetration testing is not a technique you can use to go secure a code base. It's fundamentally a diagnostic technique. And so we would go take and have the team go, if we identified a pattern of defect that they were missing, we'd go educate them about the defect, then have them go clean the rest of their code base and make sure they did that. We also went after network and file parsers, and I'll talk a little bit about that. So the first part here is really, we wanted to understand how we could go and improve the architecture of Windows and not just deal with security issues bug by bug by bug. And so if you kind of think back to earlier versions of Windows, everybody ran as administrator largely, all the services were running as local system, and so that any compromise, any flaw in any of these processes, it was basically a fatal compromise for the system. And so we wanted to address that in a couple of ways. First, we wanted to take the concept of least privilege and apply it to applications broadly. And you'll see this in the form of, we took the standard user account and enhanced it so it's a lot more functional and basically removed what many customers consider just deployment blockers in trying to move to the standard user account. The second thing is that we reduced the privilege level of admin applications so that when people do log in as administrator, not all of their programs run with all of their privileges and all of their capabilities. You know, the calculator doesn't need to take advantage of the fact that you're an administrator and have the debug privilege and whatnot, and so only administrative apps have administrative privileges. And then we even took some applications on the attack surface, like the browser, and compartmentalized it even further by putting heightened restrictions on it. The next part of what we did is we went after services, and I'm going to walk through the service hardening effort that we did in Vista. So one thing that we want to do is services have always been a point of attack in Windows. They're a point of attack because they're running all the time. They typically run with high privilege. If you're able to attack it, you don't need to wait for the user to do something to pull off your attack. And so they really have been the target of many different attacks over the past few years. So we wanted to see what we could do to